Hello guys, in this video we are going to make a simple Mograph effect in Lightwave and transfer it to Blender for rendering in cycles using GPU computing. This is a simple warming up exercise, nothing complicated. It gives you a short introduction into Blender's interface and the basics of rendering. Okay, of course we could do the Mograph stuff in using animation nodes, but if you would want to, but we don't, because honestly animation nodes for Blender is still a bit immature and buggy and error prone. I just did a quick research on this subject, and what I have seen discouraged me, and I wouldn't go that way definitely, because in Lightwave we have a working set of tools. It's pretty solid, could be better in some aspect, but it's fine for general motion graphics. Okay, let's start. We have this cube made up of several smaller cubes, and let's see how the Nodal network looks like. It's fairly simple. May seem familiar from earlier tutorials. The curve node drives the effect. I have set it on the x coordinate, so as the curve passes by, it affects the x coordinate. No, it it evaluates the x coordinates of the incoming pieces. If you set it to y, then the effect will happen on the y axis. But using from earlier tutorials, I have shown you a different approach using a null object, and with a small with a few nodes you can set up a custom radial fall off system, but I leave that for you to do. This time we are going with this simple gradient curve wipe. Sorry, the position of the pieces are affected by turbulent noise, and also I have incorporated a mesh part node, because this combining the part center and the bump output of the turbulence creates a bit more interesting effect. I think this is okay. You can leave the mesh part node behind. Let's see how does it look like with only with the noise. Okay, it's somewhat milder, but if I replug the noise into this subtraction vector, the effect becomes a bit bigger. The pieces are displaced further away from the origin, but of course I have here a bump amplitude multiplier. Without that it looks again a bit different. These things are not obligatory. You can leave some. Actually, this multiplier works better if you set it to a higher number. Then you really see that. Okay, now it became really hectic, a bit out of hand and more chaotic. So if you want to go for an effect like this, multiply it as you wish. Or if you want to have a regular effect, use only the part center, just plug it here and forget these nodes. Now we have this regular vibe. Let's see this in preview. Alright, this could work, I'm pretty sure, in a situation when doing Mograph. You don't have to use noises all the time. I just made a quick test with a ripple noise, and if we use instead of turbulence, let's see, this could be nice as well. So part center and ripples will create the displacement on the position combined with the curve node. Let's see how does it look like. Maybe it doesn't look that good. Yeah, this is fun, but of course you have to refine the settings, because this is a bit too chaotic again. So maybe the wavelength or wave speed could be less. Let's make a new, just a quick test. Wavelengths, that should be maybe 1 meter. Yeah, let's see with these settings just quickly. Oh, we have created a nice effect in no time. Okay, very nice. I didn't want to use this in the demonstration, but as you see, you always find new ways and new looks, so it's quite fun to play around with these nodes and what they do and what they don't. And there are definitely funny surprises. Okay, let's export this, because I think I like this a lot. I want to render it in Blender. Save, export Alembic. I set it to cage only. Export camera, and I just save it out. Yeah, okay. It takes a while. Yes. Go over to Blender and File, Import Alembic. It's here. Let's check the cube. Scrub the timeline. Yeah, the effect is really huge. Let's resize it. There is this arrow icon here, somewhat hidden cleverly, but we need this. And set the scale to 0.1 for each piece, or for each axis. And let's select the camera. I rename it to camera LW for Lightwave. And we want to look through the camera, so press Ctrl and hold down, and press 0 on the numeric key. Okay, now we have the camera is moving fine, but the scale is not okay. So go over to constraint, object constraint properties here, and set the scale to 0.1 as well, just like for the pieces. Okay. Now it looks fine. Let's get rid of this stupid cube. Okay. Select the cube. We will set up a shader. Just pull this aside. Use nodes. I choose this vivid orange color, and I will use metallic, specular off, and roughness somewhat less. And let's choose render engine. It's here under render properties, cycles and GPU compute. Leave the rest as it is. And I also under layer properties there is a denoise function. Use that, it's important. And under world properties we can set up using this color, the white circle environment, we can set up a HDRI environmental lighting. I have already my favorite HDRI texture here, and I just click it, I just choose it, and ray visibility is important, because now if you go to viewport shading, you see the HDRI in the background, and I don't want to see that, so switch off the camera. Okay, light, the lighting, yeah, let's adjust the lighting. Press G for move, and this light should be area. It's the, select the light bubble icon, area. You can set the size to somewhat bigger, it's, and the power to something like this, and maybe I want to rotate it. Press 0 for camera view. Let's crank it up a bit more, even more. Yeah, now we have a light. Okay, not a big deal. Let's see how does it look like in final render. I resize it to 75% full HD for faster render, and let's see how does it look like. Yeah, it's a basic smooth cube with denoise. I think we have achieved our goal. We have successfully transferred this animation from Lightwave to Blender, and we could render it out. Thanks for watching, and I hope you enjoyed this video, and see you in the next one. So cheers and bye.